Hello class. I am gonna cover some examples from the stuff that we have done in classroom before in preparation for the exam. As you know, this is gonna cover part of the snow day that we missed because of the school closure. So I have chosen this particular example on DVDs, which is very important. So it shows you how classes use other classes and other objects. So let's get into this one. So first of all, we're gonna have a look at what a DVD is. So suppose that you wanted to actually create some kind of an object that presents a DVD for you. So you're gonna go and see what kind of information that DVD is going to have. So the class DVD that you would write is going to have certain instance variables. These are called instance variables because they come with every instance of this class DVD. So every individual DVD, which is an instance of this type, so this class called class DVD, so this class represents a type. So all DVDs are going to be like this. All DVDs are going to have a title, a director, a year of production, a cost, the cost of the DVD, and you would know if they're Blu-ray or not. So that is what we consider a DVD to be. So when you make a DVD, when you instantiate a DVD object, that is, you're gonna have to give values to these things. And as we know before, a constructor of the class, which has the same name as the class, is responsible for making objects. So you would come here and say, I want to make myself a DVD. What you have to pass to the constructor is the title, is the director, is the year of production, and the cost of the DVD, as well as whether or not it's a Blu-ray. We chose a Boolean for the Blu-ray, or rather the authors of the book chose the Boolean for Blu-ray because it's either Blu-ray or not. So the answer is either yes or no, true or false. So in those cases, Boolean is a natural choice for a variable. Now, we have the this keyword. This here means that the title that you chose here is going to be assigned to this title, which means the title of this particular DVD. So you have a DVD and says put the title that you get, which is this, for the title of this DVD. Put the director that you get for the director of this DVD. The year that you get for this year, which means the year of this DVD. So when you make a DVD, you would have this. So alternatively, like I have said before, you could have done this differently, and you could have just said, for example, you could have done this differently. You could say title equals DVD title. But then here, you instead of the title, you would say call it DVD title. That way, there would be no confusion of which one is sitting for which one. But since we are calling both the parameter that we are passing and the variable that is going to have the value of that parameter, both of them are called title. This keyword is used so that you would know that this title is the title of the DVD. So this here basically says it's related to this particular object. So it's not a big deal. It's just a syntax of Java that allows you to actually specify what sits for what variable. So the constructor of this particular object, which is a DVD, doesn't do anything except to assign certain values to the instance variables. So in some other classes, you could have a constructor actually perform certain calculations and come up with fill up some of the fields in a certain way. So for example, you could come up with some, private magic, so private, say, double magic number. Okay. So there, each DVD you want to give it a magic number, let's say. And then you could come here and then you could say magic number equals, say, I don't know, cost times year of production. Now, there's something which is called a coercion here happening. So what it means is that I called this to be a double, but I'm actually putting an integer in it because the cost, well, actually the cost is double, so never mind. So this cost times year is actually, the coercion is happening, but the coercion is happening in the sense that when you're multiplying the cost, which is a double, times the year, which is an integer, then the result is considered to be a double. So the integer type is coerced into the double type because the outcome could either be double or integer. It can't be both. And so once one of the two is double, then the result is considered to be double. So let's say here you could have done, 5 times the year of production is the magic number. Whatever, it's your magic number. You can decide it to be anything. And so in the construction here, you could use some of these things and calculate something that is related to that particular object. So you could have done a magic number for DVD, which is 5 times the year of production. What's the use of that magic number? Only you would know because that's your magic number. But in some cases, you could actually do something useful with that, and you would say, I need some information and I store it when I construct an object. Now here a coercion is happening because 5 times year is integer, but magic number is double. So the result, the 5 times year is converted to double because the variable is a double. It's not that important right now, but it's something you should know. Okay. Now, this DVD doesn't have many methods because it's a relatively simple object, as you know. It just has some information that you would need. And once you create a DVD, once you instantiate a DVD, you actually decide what are the values of those things. Now, when we come here and we look at the toString method, the toString method is where we actually make use of this thing here. When we imported the java.text.number format, it's because we needed it here. And the reason for that is that, you could have avoided this and just, printed the cost without any formatting. So here, if you see, here the job of toString is to create a string that represents this particular, any particular object. So let's think about it this way. So let's open up. So here, let's say you have an object called X. The object X has a method sample, and this sample takes no parameter. Now, if you want to call X to call sample, you would write the following. You would say x.sample. go to the object X, get the method sample, execute it. And that's what it's going to do. It's going to go and execute that. ToString is a special method. So when you call system out print X, what happens is that you call x.toString. You execute toString method. Of the object X. ToString method returns a string. Of course. So here, when you look, the job of a toString method is to return the string. The string is supposed to tell you about the object. Now, if you don't have the toString method, then Java has a default one. That default one you have seen. It gives you the address of the object and the type of the object. That's all it does. So if you don't write a toString method for a particular object X, then you will not have a nice presentation of X. So if we didn't do this here, so let's say, for example, let's go here, and for the time being, let's do, let's quote out this toString method. I'm quoting this out, and I'm gonna call a new class, call it test DVD. So the job of this class is to test the DVD. And in this class, all I'm gonna do is going to be the standard string arguments. And all I'm gonna do is I'm gonna say DVD my DVD equals new DVD. So now I am calling, but with new DVD, I'm calling the constructor of the DVD class. Here I identify the type. I say I want an object of type DVD. I want to be calling it my DVD. And therefore it's a new object. That new keyword identifies that's a new object. And I'm not replacing this with something else. And then I'm calling the DVD constructor. The new knows that it's time to call the constructor of the class DVD here. So, and then I have to give it the information. And now let me cheat and sort of get the information from, well, it doesn't really matter. So the title is Titanic. The director is Cameron, and the year, I don't know what it was, so why don't I say 1992? Whatever, I don't remember the year. The cost was $32.45, and probably I'm wrong about all of this because I don't remember how many parameters the constructor had. So I'm gonna go check and see. All right, I have to give title, director, year, cost. I didn't tell if it was Blu-ray or not, and so I say true. And now, okay, I made my DVD. Now here in this, because I didn't create a toString method for my DVD, if I go ahead and print my DVD, it's gonna run the standard, the default system out, of course, print my DVD. It's gonna call the standard method, the default method here. So the test DVD is gonna running this, and this is what you're gonna see. It's a DVD object, and this is the address of it. Not very useful. Now, if I go here and I say, I want to have a nice presentation of my DVD object. So basically it says every time you try to get a string presentation of the DVD, which calling the system out print is one way of doing it. First of all, create a number format object, call it FMT. This is because my DVD has a cost and I choose to actually use a nice presentation of the cost. And for that I need to import the number format. So I create a number format object, called it FMT. Every time you want to do something, and you see format is a method of this class. So every time you want to do something, you have to create an object for it, unless you're doing things statically, which is not the right way of doing things, and we try to avoid it as much as possible. So you create a format object of this type. It's a number formatter. And number formatters have format methods. And what are we passing to it? We're going to pass the cost of whatever DVD that we are going to turn into a string. So we say, hey, well, the description is the string that we want to end up with. So we start formatting the cost, and then some space tab, and then the year, and then another tab. And then down here, then we add to that. This plus equal means add that. And remember, when we are adding two strings, we are basically concatenating them. We put them next to one another. And so I'm going to say now add the title and the tab and a director, and if Blu-ray, also add the Blu-ray at the end. But if not, then don't add anything. So basically an if statement has that property. If this happens, it does it. If not, just skips it. And so after all of this is done, the description is done. And so now return a string. So like I said before, this description, you could have set it this way. You could have said it like this. You could have said all of these things together. Sorry. You could have done it like this, and the result would have been the same. So you could do all of this in one line, but then eventually you would have to use an if to do this, because the Blu-ray goes there only, the Blu-ray description goes there only if the DVD is actually a Blu-ray. Now, if we come back to the test DVD, and this time after the creation, when that's compile it compiles, and we are the same deal is happening of this thing, this one DVD created, and I'm just trying to print it, and I go here and I run the program, and we'll see what happens. Oh, sorry, I didn't clear the screen, and so let's do this one more time. And you would see the outcome. So yeah, so the cost, it said the cost is 5. Did I say the cost was 5? Okay, let me check here what happened. Let's once again here, let's look in the constructor. Let's see string title. Oh, and this is the year, and this is the cost. I gave them in the wrong order, you see. So this is the cost that should come before the year. That is why. So it considered 1992 as some sort of a number, and so it got confused about what it was supposed to do. So the DVD object I created didn't have the things in the right order, so let me compile. Okay, let me see. No, integer year, double cost. No, actually it was correct. So let me see what have I done wrong here. So this is X. So I thought that I had them in the wrong order, but I didn't. So let's see, this is the cost, and Then it says number format cost. So let me see. Okay, here that get the currency instance of the cost, which is $32.45, and then add that. So everything should have worked just fine. Let me see why it's printing it like a 5. Okay, this might be something. Yes, I'm sorry about that. It was just that the terminal was playing games. It wasn't showing in the entire thing. It was just only showing this. All right, so as per our instructions in the description, in the toString, the description string, which is the representation of our object, is going to have the cost, formatted cost, followed by year after a tab, and then followed by the title after a tab, and then the director, and it's going to tell us that it's a Blu-ray. So this is 3245, created in 1992. The title is Titanic, and the director is Cameron, and then it's a Blu-ray. Okay, so now let's go and see this in action. Here, as you see, we have a DVD collection. The DVD collection is another object, and it's going to have printed, formatted prints of formatted presentations of a DVD collection. Therefore, we import the number format class. And so here, a DVD collection, again, like any other object, the DVD collection is going to have the instance data. So it says that any DVD collection object, it's going to have an array of DVDs, which is called collection. Now, these names are meant to represent what it's happening, and sometimes they could be confusing. So this class is DVD collection, which means that you could have many DVD collections. Each one, it's going to have its own name. And so one typical DVD collection is going to have an array of DVDs, which is called collection. You could have called it something else, but you know, the author chose to call this collection. Shouldn't be confusing. It doesn't have anything to do with the collection here. It's just the DVD collection, and also this is like the array that represents the collection for you. So you need an array of DVDs, an int count, which is basically the number of DVDs that are actually exist in the collection, and a double, which is the total cost, which is the total cost of your DVD collection data. I'm gonna pause for a second. Okay, so yeah, here we have the count, which the integer count is the number of DVDs in the collection. So once you have a collection, it's just you're declaring that I'm gonna have an array of DVDs. You have not instantiated it yet. So what you're gonna do here is this: the constructor that actually creates an initially empty collection, but the authors chose to do this out of 100. So so any DVD collection starts with 100 potential DVDs. That doesn't mean that they really have 100 DVDs. It just means that they could have a maximum of 100 DVDs. And the count is 0 when you create the collection. When you want to start the collection, you haven't put anything in it yet, and therefore you would have no DVDs in there. So that the total cost is going to be 0 because there are no DVDs in there. So if you do create a DVD collection, it's going to have nothing in it. And now you would have to start adding. So this is a method that is going to alter this particular collection. So if you do create a DVD collection, at the beginning all it has, it's an empty array. It's going to have an integer which is called count, the number of DVDs, which is going to be 0, corresponding to the empty array. and it's gonna have a total cost which is gonna be 0, again corresponding to that array which is empty. Now you come down here and you say, well, what if I want to add something to my collection? And in order to do that, you could have done this in a number of different ways. For example, you could have written something different. You could say public void add DVD, and then you would say DVD D, and then you would have to go and change certain things here. You could have said, okay, what I'm gonna do this, I'm gonna create a new DVD. So instead of saying collection count is this, I copy that, I put it here, and I say, hey, now look, get that D, get the title of it, get that D. So in this situation, in this particular, in the second one that I'm writing a different add DVD method, I could say, well, if you want to add a DVD, either give me the information related to that DVD one by one, or just give me the DVD object. If you give me the DVD object, I can go and fetch its title. I can go and fetch its director. I can go and fetch its year. I can go and fetch its cost. I can go and fetch whether it's Blu-ray or not. So I get all that information and I just put it in the collection count as a new DVD. And that's that. And now I would say total cost is, what should it be now? It should be plus equal d.cost. You have to add the cost of the one DVD that you added, you have to add it here. And then you would have to have the count go up by 1, because your DVDs just increased by 1. So now let's see why this is complaining. The reason this is complaining, and I'm not going to fix it here, is that the DVD has a private access for title, director, year, cost, and Blu-ray. So you can't access these things properly. So in order to do this, we could have made all these things public, and that would do it. But that's not the right way. The right way would have been actually to have getter methods. So you could write getter methods for title, director, etc. So for example, you could have like get title. So a get title would return the title. Now over here in my DVD collection, then I would use get title, because get title would then be public and I could use it, and I would use it as a method because it's a method, and then I would use that. But you know, we are not going to do this here, so I'm just going to comment this out. So you can either go and change the accesses of the those things to public, not the good way, or write getter methods. That's the correct way of doing it. And then, you know, here, so I could say if the fields were public, we could do this, or we could write getter methods for DVD and use them here. So that would be another way of doing this thing. Yes, and another yet a third way of doing this very same thing is basically look, you could write a similar thing and basically try to say this, say this whole bit, and instead of doing it this, just say this is equal to D. Now, sorry, then you have to use the d.cost at least. And again, the same problem. You would have, so for now, let's just comment this out. The same problem, cost has private access. So you can't get it directly, private access. But suppose that it didn't, or just, let's say for now I'm not gonna increase the total cost of my DVDs. I'm just gonna say, hey, the DVD that you give me, I just put it in the collection. That's it. I put that in the collection. So the collection has one DVD object in the particular count that I have. So that would have been another way of doing this. So you didn't really have to get the titles every time. You could just, if you had a whole bunch of DVD objects, you could just call this method on each one, and then it would automatically go inside your collection. Okay, now let's go back and see. So this was just to test things, and like you saw, we could print the one DVD in here. Now in the DVD collection, this we saw that we could add the DVD as a new DVD into our collection, and or alternatively we could have done this here. But we have to take care of what we need. We could do this, but we need a getter method to access cost. Now, how am I going to print my DVD collection? So again, the DVD collection is going to have a total cost, and I want to write that properly, print that properly. Therefore, I'm going to use the number format. And in order to use the number format class, I need to create a number format object called FMT. I use that. And then I use the currency instance of that. So I'm going to get this is a formatter object whose job is to get me a currency instance. And then I'm going to say, so this basically this number format class is going to give me a currency instance getter format. And then I put a report. It's just like a bunch of tildes, and this particular sign called tilde, and you just do that and a new line, and then you say my DVD collection, and then the same deal as before for DVD. You're just creating a string, and you're just making it grow. So first say DVD collection, then go to the next line, then the number of DVDs, and say what the count is, then the total cost, and then say what the total cost is formatted, and then go to the next line, come here and say what the average cost is. In order to find the average cost, divide the total cost by count, the number of DVDs in there. That would give you the average cost. And then say the DVD list, and then this is going to give you the list of DVDs in here. To get the list of DVDs, you actually go here and you start printing the DVDs one at a time, and you're going through the collection, which is this array. The collection is an array of DVDs that you have had. Now, if you oh, by the way, here, yes, we skipped over this, then I'm gonna come back to that. So you basically go through the collection, and each one of them you just each one of them you just print that particular DVD's information, and for that you are using the collection DVD toString. So that's one way of accessing the toString, the string representation. So you see the collection DVD, they call this DVD, this might confuse you, call it I. So they call it DVD because each one represents a DVD. So here, call it I, right? If you feel more comfortable, you can do that. But they call it DVD just because it represents a DVD. And you should know that you could call your variable whatever you like. You could use the name of your cat for it if you want to. So now come here and you say go to the collection, position I. You will find a DVD object. That DVD object is gonna have a toString method. Run that toString method. When you run the toString method of that DVD object, which is going to reside in this particular location, you are going to get a string representation of this object that is highlighted here. So equivalent to this, you could try to print it, but the point is that you're not printing, you're creating a string. So that's why you should access the toString. So if you were gonna print this directly, you could get away by just calling system.out.print. But system.out.print, when you call the system.out.print on an object, it tries to access the toString method of that object. So the effect of printing is basically calling that particular method. So now that we need the string representation of this particular object in this particular location, so DVD number 0, it's in the collection position 0. I need this collection I is going to be a DVD object. That DVD object has a toString method. I call that toString method. It's going to give me one string. That string is the representation of the DVD. And then I add that to the report, and then and I do that again and again, and then I go to the next line. So I created all of those things, all of those DVDs, put them in a long string called report. The string has new lines in it, so the string doesn't have to be in one line. It could have a new line in it. And then at the end, once I'm done, as I've gone as far up in the string in the DVD array as I have DVDs, because the count is going to tell me how many DVDs I have. Depending at any given time when you try to print your DVD collection, the count could be 50, the count could be 72. So you go all the way up to how many DVDs you have. Past that, you don't try to print anything. If you do, you're going to get weird null stuff because there is nothing in there. Now you just return that report. Now there is one more thing. So let's see in this. Let's go to the movies here. Let's compile that. In the movies, what we are doing is basically creating a new DVD collection. So it's a DVD collection object, a DVD collection called. So DVD collection is a type. The type that is designated by this class. So we have objects that are DVD collections. So an object is of the type of the class of which it is a member. So a DVD collection is of type DVD collection. A student is of type student. A DVD is of type DVD. And so in the movies, we are going to collect a new collection called movies. And you see, this is different from the name of the class, but I could have called it my collection if you like. Really doesn't matter what you call the object that you have. But if you called it, then you have to turn all of these movies to my collection also. So let's retract it. I don't want to type that much. So it's called movies. This collection is called movies. It's a new collection, so it's going to have 100 spaces for 100 DVDs, but I'm not going to do that. I'm just going to add 1, 2, 3, 4, 5 DVDs in it with the particulars of the DVDs here. The Godfather 1972, District 9 2009, Iron Man 2008, All About Eve 1950, and The Matrix at 1999. And with the other things. And then I print it, and then I would add 2 more, and then I would print it. And like I said, there is nothing to prevent, and I've said this before in class, that there is nothing to prevent you from adding the same movie, the same DVD to a collection of DVDs multiple times. If you want to prevent that, you have to actually do extra work to make sure that the same DVD cannot be added to the collection. So which might or might not be desirable, because if it's the collection is for a library, maybe you want to have multiple copies, but then in that case maybe you want to label them as second copy or something. So that would be extra work. For now we are assuming that we would reasonably only add one DVD to our collection, and we don't get multiple copies for our own personal collections. So here, after adding the 5 DVDs, you print the collection and you would see what it does, and then you add 2 more and then print it again, and the outcome is going to show you that what really happened in there. So here we compile and then we run it, and let's check the outcome. So that let's make it large so you'd see. So the first one is the My DVD collection. That's the result of the first print statement here. This print statement is gonna call the toString method of the DVD collection. Am I in the right thing? Yes. So it's going to call this. So it's going to draw a line. It's going to say My DVD collection, number of DVDs, total cost, average cost, and then print every single DVD in the collection, which, as you would see, is doing here. It says My DVD list, and this is My DVD collection. Number of DVDs is 5. Total cost, added all of them up. Average cost, decided that, and then did the individual printouts of the DVDs, for which it used the toString method of individual DVDs. Now we have repeated the same method. We have called the same method again, and this time after adding 2 more DVDs. So the count was updated, the total cost was updated, and the average cost was updated. And then the DVD list just printed 2 more DVDs that were added last to the collection, and they were not there. So the last thing that I want to do about this one is to just mention the add DVD thing here, because this is needed. You see, the way this is written, the DVD collection, the array that is representing our collection, is actually going to have 100 elements in it. So it's going to have 100 DVDs available to it. So if you reach the size of that array, so it means if the first time this happens is that when the count is 100. If the count reaches a 100, then you cannot add anything else to your array of DVDs, right? Because everything is already full. So what you're going to do is going to call the increase size. The increased size is going to change this array collection to a larger collection. So, and this is what happens in the increased size. It creates a DVD array called temp. This array of DVDs, so this is the type of it. This means this temp here, this temp is an array of DVDs. And it's a new DVD array, and the length of it, we make it twice as big as what it used to be. So the first time that this is called, this is going to give me 200, the next time 400. And that way, you know, if your collection grows very fast, you catch up with this. So, and again, they're using for starting from number 0 to the length of the DVDs. And again, this is called DVD because it's just an integer, you know. It's DVD to represent that we are counting DVDs, but if you wanted to, you could call that J or K, doesn't matter, or I for that matter, because it doesn't conflict with the I here. You see, where did we that? No, we did it in somewhere else. So yeah, here. So it's in a different method, so you can use I again here if you wanted to. So again, let's do this so that you don't have to worry about it. So I plus plus, I, and then we are done. Okay, So it says that go through your current collection, and from the very first index, which is index 0, all the way up to the last index, because I is smaller than the length, you see. So it means that it's going to be the most I gets here is going to be the length minus 1, because it's smaller than the length. And go get the corresponding indices, put them in the temporary thing here. So the first, if this is the first time you call the increase size, you would carry the 100 DVDs that already filled that array of yours, and put them in the first 100 locations of this temp. And the next 100 locations of it are going to be left empty. And now you say collection equals temp. So your old collection, which was a collection of size 100, is going to be destroyed and will be replaced by this 200 DVD collection of size 200, the first 100 of which is filled in with your old collection, and the second 100 of which is empty. And now you have 100 things to more things to fill. And so after you increase the size, now you can actually do this. That you would do this if the count already reached the size of the collection. If the length of the collection, which at the first time you would need to call this, is going to be 100, if the count is 100, you come here and you create an array of size 200. You copy the first 100 things in your collection, which is your entire collection, into this temporary one. And then you replace your collection with this temporary one. So the temporary one is the old collection plus 100 empty spaces. Now you have empty spaces, and you would add your DVD there. Now the length of your selection is now 200, and so you would not need to do this increase size unless you keep adding another 100 DVDs to it. Once you do that, then you would create an array of size 400, and now you have 200 things in your DVD. You copy them, the 200, in the first 200 places of the new array, and then copy that back to your collection. Now your collection has more space, the 200 DVDs and 200 empty spaces. And therefore, no matter how large your collection is going to grow, you're not going to run into the trouble of having to put a DVD on top of an already existing DVD. So that's what that does. There is a practical limit to this, because your collection couldn't be like 50 billion million long, because the Java can't handle that the number that big, an array that big, and so there's going to be a practical thing, but for the purposes of logical description of this, there is no limit, because every time you are doubling the size of that array. But you can only do that a bunch of times. You can't do that like 60 times. If you do that, you run out of space. Okay, so that basically explains what happened with this DVD example, which is a very, very, very good example of using an object and doing something with it. Now I'm going to use the rest of the time here, so I'm actually going to go over time, so it's going to be more than 1 hour and 15 minutes, but it's not that important. And I'm going to do the particular example that you were asking. This is something that I'd put in a quiz. So let's make a new project and call the project here, let's call this desktop, and then call this say I want to call this project the multiples. I think we called it multiples. So we did that in also the class called multiples, and in here I just had a static class. So I was gonna do this statically, public static void main string array arguments. So here the object of our static class, the object of our static class is going to be the string array. So here the object of our static class is going to be the string array arguments. So here the object of our static class is going to be the string array arguments. So here the object of our static class is going to be the string array arguments. So here the object of our static class is going to be the string array arguments. So here the object of our code was to do the following. So this is from before. Just start printing numbers from 1 to 15. So it would say 1 pass, 2 foo, 3 bar. Well, I said that it should have some tab with it, right? And then 4 foo, because it's a multiple of 2. 5, it's neither a multiple of 2 or 3, so pass. And then 6 is a multiple of both, so it has to say foo bar. And then 7, neither one is pass. So 8, by now you've learned the pattern. If it's a multiple of 2, it's foo. If a multiple of 3 is bar. If it's multiple of both, you would say foo bar. And if neither, like 11, then you say pass. 12 is a multiple of both, foo bar. 13 multiple of neither, pass. 14 multiple of 2, foo. And 15 multiple of 3, therefore bar. So this was the outcome that we wanted. Now, so let me show you a bunch of ways that you can't do this. So obviously you have to loop through numbers 1 to 15. So basically, so you say for int I equals 1 and semicolon I smaller than or equal, if you could say smaller than 16, so it goes all the way to 15, then I plus plus. Then let's see what you're going to have in the body of your for loop. In the body of your for loop, you say the things that you would like to happen. So what would you like to happen in the body of your for loop? You're going to say if I is a multiple of 2. How do you know if it's a multiple of 2? When you divide it by 2, you get a 0. Then system out print. Well, first of all, actually you want it for everything. You want it to first print I. And then not only you want it to do that, you also want it to print a tab. So that's a given. And then if it's a multiple of 2, you want it to print foo. So remember, this is how you wouldn't be doing it. And this is system. And then if it's a multiple of 3, but this is the way that most people would naturally tend to do, because we think that the computer knows what we are thinking, but it never does. So, and if it is bar, and then you could also say if it's a multiple of both. And if it's a multiple of both, then print foo bar. And then we're going to see why this is not going to work properly. So let's compile this. So, and let's run it and see how it works. So where are we here? Multiples, and it's not going to work because it's, well, first of all, let me, one of the things that we wanted to do this is that after we have done this, we would want to print a new line. Or you could say print \n. So it wouldn't be as terrible if we remember to do that so that it goes to the next line. But it's still going to be pretty terrible. Why? Because it says, you see, for 1, first of all, what happened here? Oh, we didn't, I forgot to say pass. And here I would say else system out print. So that wasn't intentional. I forgot to do it. So that wasn't me teaching you anything here. I just forgot to do it. And that was why when I did that for 1, it didn't print anything at all, because I forgot to say pass. Okay. Now you see, there's going to be a whole bunch of weird things happening. So 2 is foo, and then there's going to be an extra pass. Why is that? Because this thing here comes down here and says, okay, I did that, and then it's not a multiple of 3, and then it's not a multiple of 3 and 2 either, and oh, I have to print a pass, because if this doesn't happen, then this happens. So you could actually do it like this. So you might say, okay, I do it like this, and because, so another problem that happens is that if you look down here, when you reach 6, it says 2 foo bars. Why on earth does it say 2 foo bars? Because it prints a foo because it's a multiple of 2. It prints a bar because it's a multiple of 3. It prints a foo bar because it's a multiple of both. So ends up printing foo bar, foo bar. So you might say that, okay, no problem, I'm going to fix this by doing this. Say, if this, else if it's a multiple of 3, print bar. So in that case, it wouldn't, if it's a multiple of 2, it only prints foo. And then else if, do that, and else do that. And you would think that's kind of fixing the problem. That's another mistake that is natural to make. And you see there is no foo bars here. Why is that? Because if you say else if, then you are saying that if these things didn't happen and this happened. So when you say if it's a multiple of 2, do this, else if do that, you are implicitly saying if it's a multiple of 2, do this and done, and only do this and only do this if it is the case that that it's not a multiple of 2. So in this case, you would print bar only if the digit that you're, the number that you're looking at, it's not a multiple of 2, but a multiple of 3. And therefore, this thing is never going to be executed. Why? Because if something is not a multiple of 2, if it's a multiple of 2, this gets executed. If it's a multiple of 3, this gets executed. But only if this doesn't happen, if neither one of these two happens, this is going to get checked. Because it says else if, which means if these two things didn't happen, then if this happened, do it. But you do know that if something is both a multiple of 2 and 3, both of these things are going to happen. So it's going to just print foo and then going to go, because these are all one if block. So you can't do this. So you would have to say, you would have to write this in a way that actually accounts for this different possibilities. So one of the ways you could do this, you could say if it's a multiple of 2, do this. If it's not a multiple of 2 and it's a multiple of 3, do this. And then have another if. Let's see if that works. And now, so this if is separate from that if. It checks I again. If it's a multiple of 2, prints foo. If it's a multiple of 2, but not a multiple of 2, but a multiple of 3, it prints bar. And if it's neither one of these two, it's going to come down here, right? So the problem with this, trying to fix it this way, is that if it's a multiple of 2 or 3, already a foo or a bar is going to be printed. So this is going to act a little better. But still not the ideal one. Still, it has the foo passes and foo bars, and because not only does it check and prints a foo or a bar, it again checks if it's a multiple of both, and in that case it would print a foo bar. And if it's not a multiple of both of them, then it prints a pass. So in that case, if for example, if I is a multiple of 2, it prints a foo, doesn't print a 3, doesn't print this either, but then it prints a pass. Why does it print a pass? Because you gave it another if. So let's say the number you're checking I is 4. It says, is 4 a multiple of 2? Yes, so it prints foo. And then and then it would print it wouldn't print anything here, not a bar, because it has it's not 4 is not a multiple of 3, and it checks to see if 4 is both a multiple of 3 and 2. Well, that's not the case, but there is an else clause here. There is an else clause here, and says if that didn't happen, then print a pass. So for 4, it's going to print foo pass. You see? So one way of doing it, now I leave one way of doing this to you. So let me tell you the most logical, but the longer way of doing this. You might find a shortcut for this, and so I encourage you to try to do this in a nicer way. So you could say if I is a multiple of 2, but I is not a multiple of 3, then system out print foo. Now you could do another if, or you could say else if. Let's do this only with ifs. You could try doing it with else ifs later. So if I is a multiple of 3 and at the same time not a multiple of 2, not equals to 0, then system out print bar. Good. And now if, so each one of these ifs is calculated independently. And this is not the best way of dealing with conditionals, but it's sort of clear what we are doing here. So if it's a multiple of 3 and it's also a multiple of 2, and by the way, you could have written this if it's a multiple of 6, because anything which is multiple of 2 and 3 is a multiple of 6. So you could have written this in one sentence, one boolean. Then foobar, and eventually, if none of that happens, else. Okay, so and okay, so let me put the complete version here. So if you try to meddle with this, you will see why it's tricky to actually do it with all ifs. But I'd leave that for practice, because figuring that out is actually very helpful. And then system out print pass. So I have 4 independent ifs and not. So I considered all the possible combinations. Either it's a multiple of 2 but not 3, or it's a multiple of 3 but not 2, or it's a multiple of both of them, which I said you could write this as if I equals 0. You could say I% 6 equals 0. That's the same thing as saying that both of these two. And then if it's neither one of them, then print that. So let's first see that that works. So here, 1 pass foo bar, foo pass, foo bar pass, foo bar, because you basically went there and brutally forced it to do the exact thing it's supposed to do. Now, let's see what you get if you do this with else ifs. Well, not if you do this with else ifs. So let me take this out and sort of save it here because I wanna. Okay. All right, so let's do this and see what happens. Here's again, it says if it's a multiple of only 2, do that. If it's not only a multiple of 2, right, then probably it's a multiple of 3 only. Then do that. And then you get, so let me, now if you do this, okay, all right, so if you do it with else if, because you have all the cases covered here, you don't run into the problem of not checking this one here because you added the extra clause here, you see. Without the extra clauses, you could actually make this a little shorter, playing around with these conditions and see what are the conditions that you could actually eliminate here. So with the else ifs here, you could do this. If you try something like this separately, what is your guess that's gonna happen? You get that issue that I said, because in cases that, because you see when you write 2 separate if statements like this, the first one has nothing to do with the second one. The first one gets checked and does what it does, and whether or not those things are done, the second one gets checked. But if you have if else ifs, only one of the clauses gets executed. Not all of them can, not more than one of them can get executed. And that way you don't allow the repetition of the actions here that happens with an if here. So you can't separate this. You could do it with ifs and else ifs, or you could do it with all ifs, and the way that we did before, you would have it like this. So obviously this one is a little shorter if you do it with else ifs, but the first one, which like I said is not, and even this could be modified a little to get a little better with less code writing, but the first one that basically considers all the possible outcomes is actually the logically clearest one. And so that's why I told you that, and the rest you can actually play around with and see how this thing works. Okay, so now maybe I could actually see if I can, and this is too big, but okay. Let's see if I can sneak in another example here. So let's see, and so this is an example from the, well, let me make a new project here. So again, a project is array handling, array exercise. So test array. Now I could cover this in the class on Thursday. So here I'm gonna call this like use this like a driver thing, and so I want to make a new one and say you know, my array, or I don't know, A1. How do I call it A1? So it's just an array. So in here I would like to test an array that exists in this one. So here I would say integer array my numbers equals 5, 7, 8, 12, 45. So this class A1 only has one particular integer array thing to it called my numbers. That's it. It's a very simple class. Now in this test array thing, I want to write a method that basically gets an array and just prints the numbers of the array in some order. So I would say here public. By the way, you could not use the public thing here, so you could say void print integer array x. I call it x. Usually I call it something that is representative of that. And instead of so, and also here I could say, for example, void change change integer array x, and then integer change. Okay, so what I'm gonna do, well, so let me get another one also, integer index and then change. So here I would write this first. So I say look at x, look at index, and change that to change. You see, it's very concise, this thing. I'm saying give me an array, give me an index that you want changed, and tell me what you want me to change it to. I go get that array, look at that particular index, and I put the integer you told me to in place of that particular thing. So when you call this, you basically change one element of this array x at that particular index to whatever number you decide to. Now here, for this, I would just say for integer I equals 0, integer I is less than x dot length, and I plus plus, say system out print line x I. It's a very simple printing thing, no? I just wanted you to see how you would use that. So now, so that's in the test array, and now I haven't done this, as you see, I haven't done this statically, so I would have to create an object like this here. And so one of the things that I would do here, so I would come here, so okay, so make it static just to save time, not so that I don't create objects every time I want to use this. So I would do this, and I would say get me this, and then in the public static void main of this thing, I'm gonna say, okay, call, well, first of all, do this, print sorry, first I would say integer array test equals I'm gonna say a1 test equals new a1. This is gonna create an a1 object. A1 object has nothing in it except an array called my numbers. So I'm gonna say go do this, and then I say print a1 dot my numbers. Print is a method I have here. I'm gonna get this thing here, and I'm gonna access the my numbers of it, which happens to be public, so I can access it. Okay, here my numbers is that. What is going on? Okay, yes. All right, I wrote this to not do it statically, so okay, so let me call this static. So I didn't want to do it statically at first, but now I'm doing it statically. So here, so I say go get a1 my numbers, and I could have actually, let me do this, redo this. So one way of doing it is doing it like this, and you would have one a1, and that a1 has this array, and I just go here and I access it and I print it, and then I'm gonna go and change again a1 my dot numbers, my numbers if I manage to type it properly, and I want to change the index 0 of that to 345, and then I'm going to print it again. Okay, let's see how it works. Compile and just do this. So it first prints the thing. It says 5, 7, 8, 12, 45, and then now the second print. So let's put a line between the two prints, so that you would see that the two prints separated. And then run this, compile and run it. So this is the first print, and it went and changed the array, and then this happened. This is important for me to show you, because remember, an array is passed by reference. So it means that if you give an array to a method, whatever change the method makes to that array, it's going to be permanent for that array. So it's no longer, the array is no longer the same array after you change it. If you make a change in it, although you gave this method this array, but the method, because you pass is by reference, the method is not going to be a good guardian of it. It could make changes, and the changes is going to be permanent in the array that you passed. You see? So yes, but if you, for example, if you have an integer and you pass it to a method, and that integer is called x, for example, let me add a static integer x equals 5. And then I come here, static int g. Okay. And here I could also say, for example, I could have static add one integer, anything. Let me call it y just to, and then I would say y++. Okay. Static, nothing to return, void. Just take an integer, add 1 to it. This is a very useless method actually, because the reference to y is going to be gone after this. Now in here, let me take add 1 to a1 dot what did we call that? I just forgot. X dot 1 dot x. So get the x of a1, add 1 to it, and then system out print a new line, and then a1 dot x. Okay, so let's see what happens. It's still 5. Why? Because when you pass an integer to a method, you're passing the value of the integer. So you are putting here, instead of y, you're putting a1.x. It gets it, and in here adds 1 to it. But it doesn't go and change the original thing unless you specifically go and access that thing and actually add 1 to it. So for example, if you say here a1.x plus equal 1 and then print it, so that's explicitly going and changing that thing there. That's a different story. You go there, because it's public, you can change it. And then after you change it, you can print it again. Now this time it's 6, because you went in there manually and you added 1 to this. But when you pass an integer to a method like this, it doesn't get and change the original thing. It just makes a copy, and whatever it does with the copy. In this case, it doesn't do anything whatsoever, because it just adds 1 to the copy. And if you wanted to, you could print the copy. So let's print the copy and see. System out print copy of a1x and plus y, copy of input, so plus y. So let's do that. So if you do this time we call it, it will print a 6 copy of input 6, and then the original, when it prints it, is still 5. But here, when you change the array, you would see that that is the case. Now, here, one more thing I wanted to say is that you could do this non-statically. And then here, you could, instead of saying a1, you would have to say test. Test my number. Because test is an object. And test x, and test x, and test x. So you could do all of those things non-statically, and I mean semi-statically, so to say. And it would have been the same way. So like, you know, if you look at this particular thing, you know, at the beginning, the thing here is 5. It has 5 for its first integer, but after the change, it's going to have the 345. And these things are the same things that happen, but this time I did it with without doing this statically. Instead, I actually created an object. So you either create an object, or the fields of this class have to be static so that you could access them using the name of the class, you see. So for example, here the same class could have a static variable, static int variable equals 7. That particular variable I could access in here using the class name. I could say, for example, here, I could say system out print. What was it? The name of the class and the name of the variable. What did I call it? Why am I having such a variable? I called it var. So that's var, print that, and of course a dot instead of a comma would help. And then do this, and then also print a new line, so that you know that is the result of that one. And then do this, and come here and run this. It would print I wanted okay, so let's do 2 lines then. I wanted this to be quite clearly separated from the rest. And okay, so now it goes there. It accesses the variable which doesn't need an object to be accessed because it's a class variable. You see, this variable is a static variable, so you could access it using the name of the class. These things are not static variables, so in order to access them you have to create an object. So you have to come here and create this test and then use test and dot notation to access those things. All right, I have this is more than the time that I had allocated to this, so please, if you have any questions, bring them to class on Thursday, or email me. But if you email me, I'm very busy. If you're emailing me, please make it very clearly understandable and very clearly explained. So that concludes our video session. So we will not have a lab on Thursday. We'll just do things in class examples, and what examples I cover is going to be depending on what you ask me or what you suggest. I hope this was helpful. Good luck with your final exam preparation.